Good morning and good evening to our two guests from Japan, and welcome to this third webinar in the Insights series of webinars from CyberSec for Europe, which is one of the four pilot projects working towards the European Cybersecurity Competence Center and Network. So I'm very glad you've been able to join us this morning for this fascinating presentation from Petr Švenda, who is from Masaryk University. And he's going to be talking about towards more transparent security certifications. Certifications a number of years ago might have been considered a little dull subject, but there is a lot more material in the certificates than might previously have been thought. And what I believe Petr is going to be guiding us through is what can be discovered, what can be mined from different types of security certificates and certification. So with that, I'd like to hand over to Petr. Before that, a couple of things. I'd appreciate it if everybody could go on to mute, which is just by clicking on the green button on the left-hand side of the screen. Questions, if you have questions to Petr, please put them in the public chat, which is in the column next to the far left-hand side. And Petr will deal with them as we go through the webinar. So with that, remember to mute your system, and I'll hand over now to Petr. I'll pass you the presentation rights, which will help you present.
Yeah. Good. So welcome all here. Now we are at the same call, and my name is Petr. This is a joint work with Jan Jančar, Adam Janovský, Stanislav Boboň, Martin Frian, and others. And I will talk about certification process, but especially from the technical perspective, what we can get out of very interesting artifacts, public artifacts, which means everybody can take a look and get this data out of the certification process, as by Common Criteria, as well as FIPS140-2. So the plan is to give you very lightweight intro to these schemes. I will not talk too much about them for two reasons. First of all, I'm by no means expert on the process of doing the certification. And second one, I like to spare some time to show you some data we are able to extract from these publicly available certificates. And the data are extracted by the tools, by the open source tools we are developing already for some time. And I will show you how it works, what are the inputs, what you can get out of it, how you can use it. And based on the data we extracted from the certificates, basically starting from 1995 up to the end of last year, to have some nice division, I will show you what we can get out of this, some ecosystem insights. And also I will show you how this kind of tool is useful for vulnerability researchers as well as the defenders, someone ITsec guys owning or using some certified devices. And I will demonstrate this on the ROCA use case, which is the case of factorable keys from some smart cards we found 3-4 years ago, and I will show you what we might have been doing way easier, be the case that such tool already existed that time. And I will also try to show you some online demo because we already took some parts of data and put them online. Good. So from what place I'm coming from, Masaryk University is in Brno, Czech Republic, somewhere here. And we are doing and interested in smart cards since 2002. We worked for our national security authority and did some analysis of real security of smart cards for them. And we got hooked into this topic ever since that time. And smart cards are really pervasive. You all have at least 2 of them, likely. One in your wallet because of payment, and the second one in a mobile phone, but they are more and more widespread. Yet the smart card industry is very closed, as the hardware industries tend to be. And just to see the detailed specifications, you need to sign NDA. And this is a big issue for us as the university researchers, because signing NDA means we will have a hard time to publish our results. So that's an issue. And this framed the way how we proceed with our research, because we never had the detailed specification, not mentioning even source code of these devices. We always worked within the black box model. So we had the smart cards like this, and we were just observing what we can externally as a black box device. But there is one advantage of this approach, which means the tools we are developing to be able to analyze these black box devices can be run by basically anyone. And that's a big advantage, because if you would be basing your analysis on some private knowledge which you can't disclose, other people can't use this knowledge unless they will sign the NDA and so on. So that's our framing. And I have a task for you. I will talk about what we can extract from these already existing security certificates under the Common Criteria and FIPS schemes. And I would like to ask you kindly to think how you are using these certificates already, or how you would be using these certificates if this would be interesting for your use case, and just put the examples of queries you would perform into the chat. And later, when I will finish with the main part of the presentation, I will just take a look and try to tell you whether we can already do that with the tool, or or it's outright impossible because the data is not there, or something in the middle. So just if you are interested in all tachographs certified after some year, just put query like that. Or if you would like to compare some companies based on their products, that's another type of query. Or if you have the certificate for devices you are using and you would like to quickly learn whether you are affected by recently published vulnerability, that's another type of query. And just put them into chat. No need for specific structuring. I will later take a look on this. Good. So the promised very brief primer for certification. So there is a vendor doing some nice product, and that vendor, for some reason, mostly compliancy, decided to go for certification, like Common Criteria. So then the vendor will take the whole product and say, okay, I'm not going to certify the completely whole product. I will just say some part of the product is going to be analyzed and later certified. And that's target of evaluation. And within that target of evaluation, I will specify what are security relevant functional components. So security functional components, as called by Common Criteria. And there is some standardized lists or catalog of these, so you can pick. And I will also show that during the development and manufacturing and the whole lifetime of the product, I'm following some good security measures, like I'm doing the secure development lifecycle. I'm analyzing continuously the product for potential vulnerabilities, and I'm able to act, and so on. So these are security functional components and security assurance components. And the developer, the vendor, will write down this into security target document, which is public, which is great. And likely for most of the people, this is the most detailed document you will ever get about that product. There are also some parts that are not certified out of target of evaluation, and there are no claims about this one. And historically, vendors were creating their product based on the catalog of security functional components. They picked what is the target level, higher the better, for the evaluation, and then they were showing that they are doing the good work with respect to the requirements. That's the historical, the starting approach. Since 2010, let's say, more and more, we saw another approach where people were saying if someone is doing electronic passport, then likely they will do basically the same function in different products, but they had to implement the same standard interface and so on. So someone created something called protection profile for electronic passport or tachographs or something like that, where he already selected what are the relevant security functional components and what security assurance components has to be there to achieve some level. And then the vendors, instead of picking some functional components by their own, they will just say, okay, I like to implement tachographs, so I will just pick the protection profile and show that I conforms to all these items that are specified there. And that's likely the better approach, because if the protection profile is well written, customer can just take a look and say, okay, I'm interested only in devices that conforms to this well-written protection profile. And I said that it's more and more popular. We have the data on that. You can see that starting from say 2010, it was becoming more and more popular. This is the fraction of certificates based on the protection profile, and this is the fraction of the certificates without protection profile, the older approach. The level, the security level, you can go from 1 to 7, and you can even go a bit more, which means augmented. And you will first pick what is the level you would like to achieve, and then based on that you are getting some requirements. Internationally, up to level 2, certificates are mutually recognized. Inside the European Union, up to level 4, and there is some common criteria recognition arrangement for that. So if you will pick EL level 4, let's say, based on that you know what kind of security assurance requirements you have. Like for the development, you need to achieve this requirement on the level of 1. If you would like to go for EL7, you need to do better, and there are more strict requirements for that. Vendor is making claims, and these claims are validated by accredited laboratories or evaluation facilities. If successful, then the product certificate is given and publicly published, and there are some certificate authorizing members like French NC, German BSI, and so on. Typically, you will get the certificate for 3 to 6 years. After that time, either the certificate and product is no longer relevant and it's archived, or you can create some maintenance report which will extend the time period. If you have some small changes during the time that are relevant to certified products, you can create the maintenance report that will just say, okay, there are small changes. I can show that these are not breaching the original claims, and then you will get a prolonged period for the validity of the certificate. Good. So that's the basic approach. What are the publicly available artifacts that are produced, and we can, after the certification, get them? So security target document, the document where the vendor is describing how they are implementing the security functions and showing that they are doing this well. This is provided by the vendor or sometimes by the company doing the work on behalf of vendor to the evaluation facility. and then the facility, the lab is checking. You have the final certification report, which is issued by members of this certificate authority members, like French ANSSI, and from time to time you have maintenance reports. These are all public documents in the form of PDF, so you can download them from the web page. There are additional documents that are confidential, that were previously shared between the vendor and evaluation facilities. Sometimes you can find the references to them in the security target document, but you can't get them without NDA. Then protection profiles. These are these standardized ways how to do electronic passwords or tachographs or trusted platform modules. So these are templates. They are available as a PDF, but more and more they are also available in better, more computer-friendly form, especially these collaborative ones. Basically on GitHub, people are collaborating, creating XML files that are describing parts of the protection profiles. And that's really good because you can get some automatization later on when using these. And then you have additional metadata that are frequently generated by Common Criteria portal that has all these PDFs, and on top of that some additional metadata. So they are creating HTML files, pages where you can browse. They are also providing CSV files where you have some structured parts of information and so on. So there are other sources of public data, and that's basically our input. With respect to NIST, the overall idea is quite similar. NIST is the FIPS140-2 is more specific. They are targeting cryptographic modules. They are not interested in a certification of any security-related device. Cryptographic modules is something they are interested in, and they have two primary terms. One is module, which is the product or certified part of the product, and then the second one is algorithm, which is the way how particular product, particular module is implementing some cryptographic related functionality, like how they are doing encryption in GCM mode, RSA key wrapping, hashing, and so on. And public documents, again, security policy document that's somehow corresponding to security target from Common Criteria, and they also have the web page. So basically similar kind of the data are publicly available. Good. There are some problems with overall with this approach. First of all, it's well known that the certification is costly and taking a long time, and that works well for static and products that are usable for a long time. Typically hardware, which is not changing that frequently, and it's no surprise that smart cards and similar hardware is major part of the early certified devices as well as they are nowadays, because these certifications suits them well. And it's very unfit for quickly changing products. Imagine that you have software running in a cloud with daily updates, so it's changing all the time. So that's something where the common, very slow and costly certification is not really good approach. There are other issues though. It's hard to interpret the actual security by end users. What I mean by that, if I'm buying the product, I can likely look up what is the security certificate for this particular product. But what does it mean? It basically means that I need to trust the organization that issued that certificate, laboratory that the laboratory did a good job, and also the vendor that it was not trying to like mislead me what is actually certified. Because imagine that the product would look like this. You have big product, just very small subpart is put into the target of evaluation, then you will even formally prove that this small part works well, and then you will say, oh, I'm certified to high level. So basically, this is misleading the customer because not the whole product is certified, just a very small subpart. Protection profiles are like making the situation better here because vendor can't no longer just pick some small subpart. It has to show the conformance to the whole protection profile. Also, the product is changing, so what I'm actually getting is not really what was certified. There were some updates, and updates are likely good because some security issues were fixed maybe, and so on. And also how well the product was scrutinized by the testing laboratory. This is something where you just need to trust the whole process because you don't know how the laboratory was testing, what tools they were using, what was the settings of these tools, and what were the results. So, bunch of issues. Let's take a look how the portals where you can get the data looks like. So this is the example of Common Criteria portal, where you can just browse for your product or see what was recently certified, and the FIPS have something similar. So take a look at the random example, some particular certificate, really random example. So if you will open it as a human, you will see that there are a lot of interesting data inside. So for example, certificate number. So you can extract some unique identification. This unique identification is not unique or it's trying to be, but it's not necessarily standardized along all of the whole Common Criteria space. It's basically based on the certifying bodies. Then you can see what security level this particular certificate achieved. Here you can see that it was EL5 plus some additional packages that are higher than that. And from that, the augmented term AL5 plus is coming from. But you can get more, conforming to some Java car protection profile, also who did the testing work, what facility, and so on. If you will dig deeper, you will see that inside the text, there are references to other certificates. And that's really interesting because frequently the product is composed out of other products that are also certified. So these references are interesting also from the security perspective. If something will go wrong with the product I'm using inside my bigger product, then maybe I'm affected as well. There are various versions of cryptographic libraries, types of chips, versions of different platforms that are implemented. So a lot of interesting details inside. You can just take the text and make the word cloud, but you can do better, certainly. So now we were asking ourselves what we can do if we would have a crystal ball regarding all the certified products, what we can ask for. And then we were trying to see whether it's already in the data, maybe not really suitable for the computer processing, but at least for humans, or it's completely not there. So we were thinking about a bunch of usage scenarios. First of all, there are web pages where you can browse certificates, but we can imagine these web pages can provide more information. Because just the name and the date is not enough. We would be interested in other interesting info extracted from the PDF files that are available, but you need to go open them and so on. So that's one thing. Second thing is we already have certificates for last 25 years or something like that. So that's quite a lot of certificates, and we can get some insight how the whole certification is trending and so on. If you would go and ask someone who is deeply involved in this, likely you can get pretty accurate info. But can we get this from just public information? Everyone can do that. And can we get the hard data? So I will show you some examples later. And then vulnerability research. So if I'm a vulnerability researcher and I will find some vulnerability in a device with some certificate, can I quickly realize what other devices are also affected? Or the other direction. I have this device and this certificate is affected. Is there a link between these two? And also for like Defender for active monitoring. So what are the other certificates I shall be actively monitoring for potential signs of vulnerabilities, because they are linked to my certificate and as a component that is used inside my device. And of course, we are not just providing with the tool some catchy graphs, but we are also providing the raw data, so you can write your own additional analysis on top of that. That's important feature as well. And if you have any additional idea, just please write into the chat. We are really interested to extend the tool. So now I will talk about the tool itself. So what are the inputs for this? If you will go to Common Criteria portal, you will get some nice web pages, and basically you can download everything. And out of this, you can see that these are statistics from yesterday. There are more than 4,500 devices or products already certified. There are a bunch of different categories. You can see that the most common one is the IC, and we will see that also later on from other graphs. And so what you can download actually? You can download the whole web. So you will have an HTML file. There is already a pre-prepared CSV file. Nice, we can download that as well. And we can also download all PDF files out of this web page, which means reports, security targets, maintenance updates, and so on. When we have the PDF files, we can transform them into text, and then we can start searching for some interesting parts, like the front page containing information like who did that, what is the name of the product, certificate ID, and so on. Because certificate ID is, for example, not shown on this initial Common Criteria portal, which I would like to see that information being easily available. We can also search for any keyword we are interested in, and we can also extract additional metadata from the PDF files and so on. We can, in a similar fashion, we can process protection profiles. There are way less of them, and they are not changing that often because that's template, it's not a product. So we will take these, extract the data, and basically start creating JSON files. If you don't know what the JSON is, that's basically text file, some structured text file that is easy to work with. So we have raw data extracted, then we will pair the different data sources. So we will pair security target together with the maintenance report and together with what we extracted from the HTML file. We had to normalize and clean the data because there are a lot of things. We thought it will be just like searching for keywords, but at the end we were fighting with a lot of things, including incorrect codings and misspellings, even in the names of certificates, and incorrect formats for CSV, for example. So that's a not valid CSV that you are getting there. So you are having these in JSON, and then you can start doing the interesting part, the analysis and visualizations and so on. And of course, the goal is to allow you to do your own analysis on top of the raw data we painfully extracted. So this is basically, when I'm talking about the raw data, we are getting JSON like this. So we have a bunch of different categories. So this is a category, the type of data we are searching for, and this is particular value for particular certificate. There are a lot of them. Not all certificates are available anymore. Some are with the broken links, or the PDF are screwed, and so on. So there are more than 10,000 PDFs for certificates at the moment, including updates and so on. So you will end up with something a bit bigger than 100 megabytes of JSON, and then that's raw data. You can start to look inside. So what you can get. So now I will talk about the ecosystem insight we can get based on the previously mining the certificates. So first of all, what is certified? So what category of devices are certified? We can get out of portal the current numbers for different categories for active certificates as well as archived one. But maybe we can get more precise information if we will look over the years. And this is something you need to go and look into the certificates. So what you can see here is on the x-axis, you have a year starting from 1995 and ending end of last year. And on the y-axis, you have the number of certificates issued. And the different color here means different category of device. And you can see the most common one is the smart cards and integrated circuits. That's the most common one, the red one. You also see that the network-related devices are quite popular. Multifunction devices. Multifunction means printer together with a scanner and so on. And also other devices, which means we have the category that is quite big and doesn't fit well with already existing types of categories. And you can see how this changes over the time. You can also see here that the total number of certificates is going up because this upper link is the total number of certified devices. So last year was the year with most common criteria devices certified. If you will just look at the same data different way, you can see that the smart cards are the most popular ones, even trending up, and the other ones are there. Second question is, who is issuing the certificates? So who is saying, yes, I trust the laboratory, that laboratory did a good job verifying the claims, and now I'm issuing the certificate. So you can see here that France is issuing the most certificates, and you can also roughly see the number of them over the years. So in 2016, France ANSI issued a bit more than 80 certificates. So you also have the proportion with respect to total numbers. United States are also big on this, Germany as well, and Canada, and also Japan is here as well. You can see it here. So Japan is this line. It peaked here, but in last year it was decreasing. Maybe there is some reason for that, because when we saw this decrease for UK, which is this part, basically this is UK, then it dropped, and then UK stopped to be authorizing member. They just became a consuming member. And what is interesting is Netherlands. Netherlands were like smaller ones, but then in 2019 they went up, and now they are almost equal to United States. So Netherlands are doing a lot of common criteria certifications at the moment. Then another question: who is doing the devices or products that are certified? It's way more messy here, of course. If you will plot all the vendors, you will get a messy graph like that. But in raw data, you can start filter. So you can ask yourself, what are the top manufacturers over the particular period? And so what you can observe here is, for example, NXP had the most certificate over the whole lifetime period, STM as well, Gemalto, Samsung. No surprise, these are smart card manufacturers, either the chip or the platform running atop of these chips. But to get the manufacturers, the vendors, out of the certificates is not that easy, because unfortunately there are no unique identifiers for them, and over the time companies are merging, or the different branches of one company are submitting the certificates. So at the end, you need to apply some kind of heuristics. So here I'm showing the heuristics for BAE systems, because in certificates you can find all these three types as a vendor submitting the certificate, and you need to match them into single string. So this is one example of heuristics. We are doing a lot of them because it was not intended to be processed automatically by computers, so we need to do a lot of work here. Those four most popular are smart card related. I already told you so, and there are also big differences between the manufacturers. So you can actually start looking into the data and trying to observe some information about the company as such, because doing the certification means spending a lot of time and resources on getting the certificate. So if something is having a lot of certificates, maybe at least they are not bankrupt at that moment. So for example, Overture spiked in 2016, and then it was merged and renamed to IDEMIA, which is quickly rising since then. Another question for how long the certificates are valid. So you can just plot the histogram, that's easy to do. And then it's clear that 6 years are the most common lifetime. You can see that the values around are significantly less. Also, 3 years seems to be quite common months. So likely these are some defaults. Initially, for common criteria, there were no limits for how long the certificate is valid. So you can see that there are some certificates that were like 21 years valid. Only 6 of them, but you can see this in this histogram. Longer the time, smaller the number of certificates. But you can also look at the other part of the graph here, because these are somewhat suspicious certificates. Certificates that are valid only for a very short period, less than 1 year, say. And you can then start investigating why this is the case, because likely if something was painfully certified and then within 2 months the certificate was archived, likely there was some issue. So you can take a look, and that's interesting for vulnerability researcher, for example. Archiving of the certificates. You can process all the data and get the idea when exactly the certificates are archived. How many certificates were archived in a particular year? And again, we have graph for that. So you can see that this is the year of issuance between 1995 and 2020, where we are at the moment, 21. And we somehow see also in the near future, because the certificates do have written when they will be archived. So we can also see this into the future. And when you will plot this, suddenly you will realize that there is a huge spike in 2019. And if you will just dig deeper, you will figure out that that spike happened on the 1st of September 2019. A lot of certificates were archived, and you might start asking why this was the case. And maybe you can just call Common Criteria officials and they will tell you, but maybe you're interested what kind of certificates were picked for the archival, and what were the criteria to do so. So we can get this from the data, right? What we can do is just take all the data, all the certificates, filter them just to the small subset of the certificates that were archived on particular date, very easy to do. And then we can just run all the analysis as before, just with a smaller subset, and look what is happening here. So first of all, we can see that mostly smart cards related and integrated circuits related certificates were, were archived. And again, you can see that you can see this over the time. So for example, this means that in 2019, say 15 certificates from the year 2000 were archived. And you can also take a look what certification bodies are revoking or archiving not revoking, archiving the certificates, and you can see that they are these two, which is Germany and France, and also Norway and Spain somewhat. Okay, so it's not just single authority doing this. And you can also look at the lifetime, and you will see that almost exclusively certificates 6 or more years old are archived. So very likely it was just a cleaning event where they just wanted to get rid of something that is too old and just introduce that from now on all certificates had to have clearly archival date specified and so on. Security level of certificates. So we are talking about the different levels of common criteria certification from 1 up to 7. And we can have augments, which means it's something between one level and the level up. This is signified by plus. And we can just plot them, right? So what you can observe here? You can observe that we are getting EL4, which is the only inside the European Union recognized level without need for additional arrangements. So this spiked here in 2011, then it somewhat went down, but it's more or less stable over the time. Then we are getting more and more EL5. So it's increasing. So basically the security of the products on average is increasing. We are getting also EL6 plus increasing, which is nice. So we are getting more and more secure or certificates to the higher level of security as per common criteria. And you can also see this guy here, which is the security as specified by specific protection profile. And that's the most popular level right now, because more and more certificates are showing just the conformance to particular protection profile and then inheriting the level based on that protection profile. What is the issuance frequency per LN year? We just described this, so I will just quickly skip this. What is interesting is that we even have EL7, which means formally proven plus, which means something on top of that. But basically, it's the signs that over the time, common criteria is, let's say, extended with more and stricter functionalities. Not functionalities, but rather the means how to show that your process is proper and more rigorous, and then you are getting even this higher level than 7. What is important is that the level of security is different between the different domains, between the different categories of certified products. So if you will take the smart cards domain, the biggest one, and you will plot the distribution of the levels, you can see that 4, 5, 6 is the most popular one. Very few of them below 4. But if you will take operating systems, which tend to be more complex and therefore naturally harder to achieve and being certified on higher level, like it's very hard to prove that Windows operating system is formally correct. That's really difficult to get the level 7. So you can see that the operating systems tend to be 4 and less, while smart cards are 4 and up. Again, with the tool and throw data, you can just simply filter the category and then rerun all the analysis to get these graphs. Security assurance components. These are the parts that are required by the particular level. If you would like to go to the particular level, you need to follow some good security practices within the development and the way how you specify the product and how you maintain the whole life cycle of the product with the support and so on. You can see this on this right up table. So that's taken from some version of Common Criteria documents. And basically, if you would go for EL4, you know that you need to do the functional specification up to the level 4 and something else up to the level just 1. So you can go through all certificates and see what actually the devices are using. What is the most common type of security assurance components as mined from the PDF files of the certificates. And it's not that surprising. You can see that the functional specification is used by the majority of certificates. They do have some development security defined, and here you can also see the level, because these are without the level, so likely these are keywords that are just talking, yes, we do development security, and later on we also do development security with the requirements corresponding to the level 2 independent testing. You can also look at the very infrequent security assurance components and then ask yourself, is this like a good situation? Shall we improve some parts of them? So for example, vulnerability analysis is to the high level is rarely used. So you can then look what are these 2 certificates that are mentioning this high level and see whether they are like really robust and hardened products. Because you have the levels of the security assurance components, then you can also plot a heat map. So I'm not really digging into details here, but more certificates are shown with particular level, darker the color, and you can start reasoning about this. You can compare to companies based on what is the level they are achieving, and so on. I was mostly talking about the common criteria, so let's take a look at some results from FIPS. We don't have we have similar results for FIPS, but we haven't yet enough processed all the FIPS certificates here, so I will just show you some of them. These gray parts are from common criteria, so you have some comparison between these 2 schemes. So this is for common criteria, and now I'm showing you the results from FIPS, so the color ones. So you can see that overall, the number of FIPS certificates is a bit smaller than what we are getting with the common criteria, but like somewhat comparable. They do have different levels, though. The common criteria levels are different from the FIPS levels, so it doesn't make sense to directly compare them, but you can at least see that what for common criteria, this is level 1 plus something else, this is level 2 plus something additional from the higher level, and so on. With respect to validity time, FIPS certificates are quite consistent. They do have 6 years, and only a few of them less and few of them more. So that was some insight into the ecosystem. We have way more graphs. It doesn't make sense, I think, right now to show you all of them. What makes sense now is to talk about some example use case, how you can use this to facilitate the work of a vulnerability researcher. So I will talk about the Roca case, which is the vulnerability we found in 2017, and it was vulnerability that allowed you to take the public key of the other party, take the public key out of certificate, say. The certificate is publicly available, so no issue with that. And then for a few thousand euros of electricity, you can compute the private key. So pretty serious vulnerability found in smart cards by Infineon. And we found that issue, therefore we know how it went, and we can compare how it would be easier for us to assess the impact if we would have a tool like I was describing before. So let's take a look. First, in October 2017, it was publicly disclosed that vulnerability like this that exists. So maybe you are ITsec guy reading register newspaper, and you found, okay, there is some Roca. So am I affected? How to quickly figure out? So you can quickly extract some keywords to Google for Roca, Infineon, RSA. You have CVE, but if you will open the CVE database, they mainly talk about trusted platform modules, which was a bit confusing, and you also have the name of the library and so on. So if so, naive idea would be, I have certified product, so let's look into the Common Criteria database and look for RSA lib, because that was flagged like the source of the issue, and just get it. But you will get just 3 hits, which is very, very few, and definitely not corresponding to reality. So maybe you will say, okay, I will search for the ID of the library, because RSA lib, that keyword, it can be misspelled, there can be space between the RSA and lib, and so on. So if you would use the version of the library, you will get more hits, 46 actually, but you need to go and download manually all the PDFs and then inspect whether it's relevant to you. And very likely, unless you are directly using these products, you will think, okay, I know that some products are vulnerable, but my product is not directly among this set of 46 hits. So am I vulnerable or not? Also, you don't know whether the particle version is vulnerable or not, and whether if your device is using the vulnerable smart card and vulnerable library, will it even mention, like maybe just searching the text is not enough to realize that you are using the vulnerable functionality. Also, you will figure out that there are a lot of certificates for these Infineon chips, and it's hard to tell whether your device, maybe some IoT device, is using one of these Infineon chips. So a lot of issues if you are just ITsec guy and you like to get this from the public sources. We had the issues as well as the vulnerability researchers, because we found the issue, but we found it in one single card we had at the time, so one type of cards, and we were wondering, is this just a flaw in this particular one card or type of cards, or or other families impacted? What systems are having this chip inside there, and how to check that other devices are not impacted? So we were wondering this, and I will show you quickly how to use our tool to address this. And also I will show you how to address another interesting thing that happened behind the curtain in 2017, because there was an incident report coming from Austria. It was because it was not really public, but it was circulated among the IDAS members, because there is a regulation, Article 19, which said if you will find an issue with your IDAS related, which is basically digital signatures related devices, you need to let other members know. And Austria, some e-health certificates were revoked, roughly 1,000 of them, and they said, okay, we are doing this report. This is the number of report, and I will show you also the report as such, but it turns out that it was unspecific third-party failure. There was some concrete vendor, but it was not Infineon one. By the way, I need to say that Infineon handled everything really, really well, like very professionally. I don't like to blame them for anything, like they did a good job here. But Estonia, for example, missed the fact that this incident report was really relevant to them, and that their platform used for Estonian ID cards was also affected. So the question is also, would our tool be of help at that time? So let's start how to use the tooling. So the, let's say, naive or idealistic idea would be, okay, we already can process all certificates. We can find the certificate's ID, and we can find all other certificates' IDs referenced by particular certificate. So we can figure out that this certificate, for example, is referencing this one and this one. So we can make a graph out of this, and we can start searching whether the particular certificates are related, and if yes, then act. So for example, if new vulnerability is found in this one, these are potentially vulnerable because they are either directly or indirectly using the affected platform. So you can like take them for closer scrutiny. But there are issues, as always. First of all, the graph is way more complex than what I was showing here, because here, that's a real part of the graph, but very few components are like this. Most of the components are like this. So a lot of different references and so on. Second issue is, we can't be sure that the graph is complete because the references are inconsistent, sometimes with the typos, and sometimes they are talking about using some other component but not really providing the certificate ID. So we need to process this automatically. So for us, it's hard to get the complete graph, but at least we can get something. The next issue is that no such graph was provided or is provided by Common Criteria. So we need to dig this out, but now we can do that. So when you are having this data, this large graph of references, you can start looking how referencing complexity looks like. So you can, for example, list out the certificates that are most referenced directly by others. So their certificate ID is within the document of other certificate. And based on that, you will figure out that NXP is holding the first 3 positions, and there are some others. If you will also take the indirectly referenced ones, which means one or more hops between them, the situation changes, and the certificate which is the most indirectly referenced ones is coincidentally the Infineon certificate with the Roca vulnerable library. So this library is the library with the vulnerability. So this basically is some side channel information that yes, likely this will be a big issue because this certificate is highly referenced and highly used. If you will just plot this as a subgraph, take this one single most reference certificate, you can see how the graph look like. It does not mean automatically that this small guy here is using vulnerable functionality from this guy. Likely you can't automatically get this information, but at least you somehow limited the number of certificates to search 4. The issue is there are more than 100 other certificates with the same library that are not plotted here. So, so this is one certificate with the vulnerable library. Some of these certificates might be also with the vulnerable library, but graphs like this, you have more of them. This is the biggest one, but you have more of them. So let's take a look at the story of this Austria incident report. So this is excerpt from the report. You can see that it was created on June the 20th, and it was then distributed among the partners, and it was saying, yeah, we have the issue. The issue is in particular with these devices. Conveniently, these two strings are the names for the certified devices. So very quickly you can get the certificate IDs out of these. They were saying that these devices, affected devices, were by Atos. And the issue was a weakness in asymmetric crypto library. And that was what was circulated. Also, you know that RSA is to be blamed, ECDSA is safe. So can you act on this, and how hard is to act on this? Because Estonia missed the fact that they are vulnerable based on this report. So let's take a look. So you will take our tool, which is written in Python, by the way, and you will run the tool, and you will use these initial keywords, the certificate IDs, you extracted from the Austria report to run the tool. And you will get some analysis, and this analysis is showing you that this is the first and this is the second referenced certificate, that this one is referencing only one other certificate. This is not really certificate, this is some list of recently certified BSI certificates. So, and this one as well. So they are actually referencing just one other device, and that one other device is Infineon Security Controller. The second that was in Austria report was referencing this one, and again adds some other Infineon security control. The only difference is in the small revision of the chip of integrated circuit. This is surprisingly small graph, I need to say, because it's not really populating to this large number of devices. So this Austria cards were just using another one certificate, and that was it. There is the library, but just based on this search, you need to add some additional thinking that, yeah, they were talking about the RSA, both of them do have this version of library, maybe this is the library to be blamed. But within this graph, you don't see the Estonian certificates. So Estonia might say, okay, I'm fine. I'm not within the impacted graph. So let's go other way around. So let's now take these two affected platforms and go up all the certificates that are referenced by these. You can do so. Another switch, do find affected, just seeded with the Infineon certificates this time, not the Atos ones, and you will get way larger graph where in red you can see these initial two seeded certificates and a lot of other certificates. So all these might be affected either directly or indirectly by the vulnerability in these two certificates. 127 found, but Estonian platform was not among them. So unfortunately, just running this simple analysis would not tell you, yes, your certificate is potentially affected. So you need to do more. The issue is here that we started only with 2 Infineon certificates, and there were way more Infineon cards vulnerable here because more of them were sharing the same library with the same bug in implementation. So maybe you can build the initial set of seeds for certificate IDs, not based on only 2 of them, but you can base it on target keyword. In our case, target keyword might be the version of the library. So let's do so. And if you will, again, use our tool, you will run it, and you will in total get 282 directly or indirectly referencing certificates. Estonian one is included, which is great, but it was included for 2 reasons. One, it directly referenced a chip, Infineon chip that was vulnerable, which was this one, but it was even directly mentioning the vulnerable library. So would the Austria report being explicit about the library, then it would be very easy to find whether you are affected or not, at least likely. Good. So the situation from the Estonian point of view was they had 2 certificate IDs from the report. They can find the underlying platform, certified platform, and then they can go up again and see what are all the certificates that are directly or indirectly referencing vulnerable platform. And this graph is showing this. But that's not complete picture. If you would search based on the version of the library, you will get more complete picture and way more certificates, especially the older ones. And the Estonian platform is somewhere here, so it was missed by this part as well. So now let's go towards the end of the talk, preparing for future vulnerabilities. Because so far we talked about the vulnerability that was found, and then we need to assess what is happening. So let's do the other way around. What are the other certificates to monitor if I have the certificate with particular ID? So as an example, just random example, I took some electronic passport platform by Gemalto, eTravel. I have the certificate ID. I took it because it's a recent one, so it's from 2020. And I will just run tool and ask, tell me what are certificates or certificate IDs that are either directly or indirectly referenced by mine. And again, I will get some graph, this time conveniently small. And I can start analyzing what are the companies I'm dependent on. And you will see that I'm dependent on Gemalto, no surprise, Infineon, Thales. I'm also dependent on Gemalto with small g, which means we still need to do some additional heuristics because some company did the certificate with small g in the name of the manufacturer or vendor. And I can also look what is the level of security and so on. So basically, you can, by some mean, limit the number of certificates and then rerun our analysis, and you are getting all these graphs basically for free. And now, finally, the demo. Hopefully, it will work. So I will just switch to demo. And can you see that? Yes, likely yes. So what is work in progress is we are extracting the raw data from the certificates. We are putting them into big JSON so you can do all the analysis, but you can also take this raw data and use them to generate a new web page for certificates where you can quickly, easily browse all the certificates. So let's take a look at common criteria. And at the moment, we have 3 main functionalities here. some big graphs showing you the components, how they are connected. You can do searching, so you can basically, based on your limits, you can search the specific devices, and also some analysis. So just quickly how it looks like. This is the graph for common criteria based on the certificates ID we extracted. So you can take some particular item, you see what other items are relevant to it. You can even click it if this will work. You can click it. Yes. No, not yet. Now. And it will just take you to the web page, which is specifically for one particular certificate. You can get the basic information. That information is already available on Common Criteria portal, but we are extracting more information in more readable form. You can, down here, you can see the graph with the just subgraph with the components. So these are the other certificates that are somehow relevant to this one. You can get the raw data. So you can, for this certificate, you can just download the raw data and play with that. You can also look at the data we already extracted, like what kind of cryptography the particular certificate is using, and what are the security relevant references, like security assurance requirements used here, and so on. So some information regarding this. You can go searching. If you will type, you will get the list of search. You can limit it and so on. Like nothing really surprising here. And some results. At the moment, very few of them, because most of them are still just offline, done locally. So that's for the web page, work in progress, but this can be created based on the raw data we have. And I will now just switch to slideshow and basically finish. Just the graph for common criteria is more dense than graph for FIPS. That's interesting. The FIPS devices, the modules, are not referencing each other that much as is the case for common criteria. I'm already over the time, so my point here with the certification was maybe we can mimic the way how continuous integration works for software development, and we can do the same for continuous certification. And what is important here is that we need open tools here, because in my view, as researcher as well as end user of certified devices, I would like to know how the laboratories did the work, what tools they were using, what was the settings, and I can rerun it. So for that, I need something that is open and well documented. So certificates in future hopefully will be like enriched with a clear description. What tools were used? What was the setting? What were the results? And I can rerun all the analysis later on. Good. So 2 steps. Get the better interpretation of what we already have and get more information about the certification process in the future. As a part of the CyberSec for Europe, we are also developing the tooling. We did that over the past 10 years. We were releasing the tools we did for the vulnerability searching, and we are now incorporating them into something that can be already used, especially in the domain of smart cards we are working in, but hopefully in other domains as well. Good, so what are the take-homes? That's the last slide. Certificates contains trove of interesting data that are accessible without NDA, which is great, really great for for us. Take a look if never searched these certificates. A lot of interesting data from the technical point of view. We will soon release the tool as open source. It's already developed on GitHub. It's just not yet public. This allowed us to get ecosystem insight, and we did the analysis we were like either directly interested in or thought might be interesting ones. If you have more of them, basically questions you would like to ask, let us know. We are very happy to work with you to answer them. Then it's a nice tool for both attackers as well as defenders in vulnerability analysis. And the overall point, it was not easy to extract the raw data out of these certificates and make sense of them, because the certificates are written primarily for humans. And I hope this will change. There are already some signs like this collaborative protection profiles, but we really hope this will change. So that's all for the presentation as such. Let's take a look whether we have some questions in a public chat. And so it seems that there are some. So what I will now try to do before I will let you ask any question you would like to get answer to is basically discuss whether it's even possible to get that kind of data out of the tool and the raw data we have at the moment. So Adam Janowski is asking, when they're qualifying for certification, I'd like to know what security measures are used by other products. Same category. That's very easy to do. You will just take the large data set and then filter it based on the competitors, say, or based on the category, and you will learn what they are using, what are the levels, what is the distribution, and so on. So that's easy to do. Very, very simple change. What parts of products are most often outside the target of evaluation? That's very interesting. We can search inside the documentation for phrases like outside of target of evaluation and so on. So we can get this, but so we can extract for you quickly the sentences, but then a human has to look for and interpret them. In some future steps, we plan to use some natural language processing, but this will be always a hard task to make sense from few sentences what they are actually excluding. Kai is asking, in which product is privacy related? This is a security okay, what is the acronym SR? It's if this talks about the functionality related to privacy, then that's easy to do as well. You will just filter the products based on what are the security functional requirements for privacy, and then you will get it, and you will get it even with the levels of privacy. The only question is whether the common criteria is specifying enough the differences between the different aspects of privacy. Samsung Galaxy Note 7 was discontinued 2 months after the release for battery issues, and that might be the reason. Yes. That's likely the issue, and also the reason why, likely the reason. Right? Could it be that independent testing includes security testing as well, potentially covering vulnerability analysis? Or independent testing is only concerned with functional testing? Here, I don't have a clear answer. I am not really deep enough with the overall process. So I know that there is some vulnerability analysis and assessment that has to be done, but how exactly and what are the requirements by particular lab on particular level for that common criteria defined requirement, I don't know. And this is something that I would love to work with someone who is deeply involved in doing the certification itself, because we know something from our view of black box vulnerability testers, basically, and then what we can see in the data, but we are missing the experience from someone who is doing this for several years and knows how the whole process look like and work. So if Dorothea would like to contact us, and or anyone else who is experiencing this, happy to work with you. Does anyone have a hypothesis for the rather pronounced decline in the number of certifications from 2015 onwards? This is not true for common criteria. Common criteria are more and more of them, based on the data at least. FIPS, yes, there is a decline, and I don't have really the reason for that. It's not that extremely significant, but it's visible and, let's say, statistically significant. But I don't have explanation for that. Yeah, and you are referring to FIPS. Okay, good. So no, I don't know. If anyone knows, just put this into the chat. Can you get certified when using component that was not certified or certified with a lower assurance level? Again, not expert on this one, but I would assume that if you would like to go for a particular level, you need to show that whatever you are using is fulfilling the requirements for that level. So if that was certified for the lower level, you can't just say, I'm using it correctly, just give me the higher level. You need to show that that part is also performant with respect to higher level. But that's just my guess. Can we access the tool? Ask for, okay. I will. I need to discuss with Jan whether the tool is ready for many people. But very easy to. Okay, I will give you the password. You just need to promise that you will not run too many requests at the same time. So the certs is username and password. Jan, speak out if you don't like me to be giving the password. And the password is right? Okay, Jan did that. Good. So Jan just put the username here. Just go ahead, play with that. Just important thing, what you see on the web page is not the complete data. Like if you're interested in analyzing the data more, just get in touch with us and we can give you the raw JSON maybe, so you will have the complete data. And that seems to be all. So are there any other questions that were not asked here in the chat?
If anyone has any questions to Peter, we can always follow up later by sending an email to either Peter directly or to friends@cybersecforeurope.eu. So with that, I'd like to thank you very much, Peter, for that extended, fascinating. It
was long, right?
It depends. It wasn't short. But I think your presentation was really fascinating and compelling, and you kept the audience interested. So thank you again. If we were face-to-face and live, everybody would clap now. It's kind of a bit weird to do this with an online thing. So for those of you who might have come late, this session is being recorded. And so it will be available on the website, on the CyberSec for Europe website, in a day or so, and we will send a notice to everybody who's attended and also those who didn't attend as to where to find it. There was obvious interest in the tool that Peter talked about, SecCerts, and as soon as that is made available, we will no doubt blog about it on the CyberSec for Europe website. And if you're registered as a friend of CyberSec for Europe, then we will send a notice to the friends mailing list. Yeah, the next event in the Insight series will probably be in March. We don't have anything firmly set yet, but something to look forward to when we do figure out what it's going to be. And as usual, we'll notify you. So with that, I would like to thank Peter again for his comprehensive and really well presented expose on the certification and mining tools, and look forward to seeing you all again. So have a great day and goodbye.
Thank you for coming. Thank you very much.